Hi, my name is Donald York, and my partner is Jonathan Funk, and we're here to talk about percentile.
A percentile is a measure used to indicate the value below which a given percentage of observations in a set fall. When solving percentile problems, we might be given a PDF function and look for an x value that will give the probability of a given f of x. We'll also discuss applying this concept of looking for an x value on the horizontal axis to standard normal and other distributions.
When given the following PDF of a continuous random variable, we are able to find the percentile denoted as p. In order to find the value of a certain percentile on the horizontal axis, we must integrate the PDF with respect to the limits outlined in the function. We are integrating from the lower bound to the value that represents the point corresponding to our given percentile. This will help us find the area of any given percentile. In a continuous distribution, we denote percentile p as a decimal between 0 and 1. Let's say you got a 1450 on your SAT. If this score is at the 95th percentile, p is equal to 0.95. This means that 95% of scores are below 1450 and only 5% of scores are above it. In a continuous distribution, we also know that the median would be at the 50th percentile.
A percentile in a standard normal distribution is like a continuous distribution where p is between 0 and 1. In a standard normal distribution, there is now a z-value along the horizontal axis that corresponds with the percentile. For example, the 88th percentile on a standard normal distribution curve is the area under the z-curve up to where your corresponding z-value lies on the horizontal axis. We can find that data value that corresponds to the percentile when given the mean and standard deviation of the standard normal curve. The data value is equal to the mean plus the z-score from the table times the standard deviation. The upper-tailed area under the curve to the right of the value corresponding to a given percentile on the horizontal axis is known as alpha. Alpha is equal to 1 minus the area of the percentile. Z alpha is the value on the z-axis that the percentile goes up to for a normal distribution. Chi-squared alpha and T alpha follow the same idea, but for the chi-squared distribution and normal distribution respectively.
Let's practice with an example. After manufacturing, hockey sticks are normally cut down to a uniform size before being shipped off for sale. The mean stick length is 72 inches with standard deviation of 0.68 inches. What stick length L will ensure that a longer than the mean hockey stick occurs only 0.87% of the time. Now pause the video and with the given variables, find L with the equation. Let x equal the length after manufacturing. The probability that x is greater than L is going to be 0.0087, which was given to us as the percentile. Equally, p, the probability of x being less than or equal to L, is equal to 0.9913. Thus, L is the 99.13th percentile of the normal distribution with our given mean and standard deviation. Find on the table the z of the alpha 0.9913, which is equal to 2.38. Now calculate L. L is equal to 72 plus 2.38 times 0.68. You should get 73.6184.
For our next example, calculate the 82nd percentile for the given PDF. Pause the video and take a minute to try. If given an irregular PDF function, we take the integral of the given function with respect to y from the lower bound to x. This integral is set equal to our percentile. After calculating, we find that x is equal to 3.473. Pause here to examine the integral. The previous problem was irregular, so it doesn't follow any specific distribution. This means that our answer, 3.473, is the 82nd percentile of the given PDF. This means that 0.82 is a percentage of the data that lies to the left of the point, between 3.2 and 3.473.
Some applications of percentiles can be used in healthcare, when you're reporting infant and child weight, height, and BMI, reporting of scores from norm reference tests, and education, such as experiments, research, and studies.
Thank you for watching.